Hey everyone, and welcome to today's Explainer. I am absolutely thrilled to have you here because, honestly, today we're unpacking something that is going to make your lives as developers significantly easier. We're demystifying the Dilnaka SDK. Now, if you've ever wrestled with secure file storage in your apps, you already know it can feel like a total maze of complex permissions and really clunky workflows. Well, consider this explainer your map right out of that maze. We're going to see exactly how Dilnaka serves as the ultimate developer tool for seamless, highly secure file management. So let's just dive right in.
Right out of the gate, we have to talk about the golden question. How do you actually upload files directly to S3 without just exposing your AWS credentials to the world? It's a core architectural problem, right? It's plagued technical architects for years. You obviously want the performance of pushing files straight to the bucket so you don't completely bottleneck your own servers, but handing on your AWS keys to a client application? No way, that's a massive security risk. It's a really tricky balancing act. But as you'll see today, Dilnaka has engineered an incredibly elegant solution to this exact problem.
To map out our explainer today, we're going to cover 1. The secure architecture, 2. The unified multi-language setup, 3. The core upload lifecycle, 4. Handling large multi-part uploads, 5. File access and endpoints, and finally 6. Understanding limits and quotas.
All right, let's get started with part 1, the secure architecture. The foundation of this whole thing is the Direct-to-S3 model. The absolutely crucial point here is that the Dilnaka SDK acts as this highly efficient, highly secure middleman. As the definition points out, the SDK never receives your AWS credentials. Literally never. Instead, it talks to your backend to grab a temporary, presigned upload URL. It then uses that specific URL to push the file directly into S3. So it's doing all the heavy lifting of a direct transfer while keeping your AWS keys completely isolated and safe on your backend. It's a true zero-trust approach to client-side uploads, and it's just beautiful in its simplicity.
Moving right along to part 2, the unified multi-language setup.
What's really brilliant here is the sheer consistency of the developer experience. Dilnaka has totally nailed that write once, run anywhere motif. Whether you're installing via PyPy for a Python project, using NPM for Node 18+ with TypeScript, or pulling a package via Composer for a PHP 8.1 app, the day-to-day experience is functionally identical. The variables, the logic, the lifecycles, they don't change just because your syntax does. For full-stack teams jumping between different languages all day, this is a huge breath of fresh air.
And speaking of that consistency, setting it up is honestly a breeze. The SDK really only strictly requires one thing, your API key, safely tucked away in a .env file. But you also get these really powerful optional variables. Notice the timeouts. You've got your standard Dilnaka timeout defaulting to 60 seconds for basic JSON API requests. But look at the Dilnaka upload timeout. It defaults to a full 300 seconds. Why so long? Well, they intentionally set this per-part transfer timeout way higher so that if you're pushing a massive chunk of data over a really spotty, slow network connection, the upload doesn't just instantly drop and fail. It gives the network time to breathe and recover.
All right, part 3, the core upload lifecycle. Let's trace the actual journey of a file.
So as a developer, you literally just call one single upload method. That's it. But underneath, the SDK is magically orchestrating this perfect 4-step journey. Step 1, it reads your local file path. Step 2, it reaches out to your Caspian backend, that's the expected backend contract, and says, hey, I need a pre-signed upload URL. Step 3, the second it has that URL, it bypasses the backend and pushes the file directly to S3. And finally, step 4, it pings the backend one last time to complete the file record and confirm success. Boom! 4 complex network steps executed flawlessly by one line of code.
Which naturally brings us to part 4, handling large multi-part uploads. Because look, that basic flow is amazing for a standard profile picture or a PDF, but what happens when your users decide to upload something absolutely massive?
Take a look at this number, 104,857,600 bytes. Put simply, that is exactly 100 megabytes. And this number is absolutely critical because it serves as the default threshold for multi-part uploads. You see, the SDK is constantly monitoring file sizes behind the scenes. If your file is under that 100 megabyte mark, it executes the small file strategy, just a single pre-signed put request for a quick instant transfer. But the exact millisecond your file crosses that 104.8 million byte threshold, the SDK automatically, without you writing a single line of extra code, pivots to the large file strategy. It converts the whole process into a resumable S3 multi-part upload,
streaming the file in small, manageable chunks.
And this chunk streaming is basically magic for your infrastructure. Because it's only streaming the file from disk one part at a time, your memory usage stays completely flat. You could be uploading a 10 GB 4K video file, and it is not going to crash your server's memory. Even better, if your Wi-Fi randomly drops for a second, the SDK automatically retries just the chunk that failed using a fresh presigned URL instead of throwing away the entire transfer. And if an upload ultimately just can't finish for whatever reason, it automatically aborts the whole process, so you don't end up paying for dangling, useless fragments sitting in your S3 bucket forever.
Now, having everything happen automatically is a lifesaver for 99% of use cases. But we're developers, right? We like having control. If you want to bypass the magic upload method and build your own highly specific logic, Dilnaka exposes all these lower-level methods. You can manually create the layout, grab presigned URLs part by part, finalize everything using e-tags, or trigger your own aborts. So you get the absolute convenience of automation, but you retain the power of total manual control whenever you need it. Let's pivot to Part 5, File Access and Endpoints. For the SDK to actually do all this cool stuff, it expects your Caspian backend to fulfill a very specific contract. It universally relies on these 4 shared endpoints, and this is true across TypeScript, PHP, or Python. It needs a /presign endpoint to start the uploads, /complete to finish them, /delete to get rid of them, and crucially, when it's time to actually read those files, it relies on get/access URL.
So when you actually want a user to see an image or download a document, you just call the getFileAccessURL method. What's awesome here is the flexibility. You can pass in an expires in parameter in seconds, which just tacks right onto the query string, letting you generate these highly secure, short-lived download links on the fly. Try to pass a negative number? The SDK is smart enough to just reject it. And if you don't specify an expiration at all, it seamlessly falls back to whatever standard time to live you've already configured on your backend. Super easy.
All right, let's wrap up with Part 6, Understanding Limits and Quotas. Dilnaka breaks down its economics incredibly clearly, which we love to see. For testing things out, the free plan gives you 2 gigs of storage and 5 gigs of bandwidth, but keep an eye on that overage behavior. Once you hit the limit, it's a hard stop. It pauses file serving. However, when you step up to the Pro and usage-based plans, the system is explicitly designed to keep your business online. If you blow past your monthly bandwidth on the Pro plan, you just pay a flexible overage rate of 12 cents per extra gigabyte. But, and this is a huge stress reliever, they implement hard safety caps. The Pro plan caps overages at 500 gigabytes, meaning you are never going to wake up to one of those apocalyptic surprise cloud bills.
And for any CTOs or lead devs out there currently mapping out infrastructure costs, pay very close attention to this next detail. Uploads do not cost you bandwidth. Pushing data in is entirely free. You only burn through your bandwidth quota when data goes out, meaning reads and downloads. This makes total sense because Dilnaka is essentially just authorizing the delivery of that file from your S3 bucket to the end user. It's an absolutely crucial distinction when you're modeling your costs.
Well, we have covered a tremendous amount of ground today, but I want to leave you with this direct quote straight from their source documentation. Your backend remains responsible for API key validation, S3 key generation, and read URL expiration. See, Dilnaka handles the heavy lifting gracefully. It manages the chunked streaming, the network retries, the memory profiles, all those direct-to-S3 handshakes. But at the end of the day, it is a tool meant to empower your architecture, not replace your own security logic. Which really begs a fascinating final question for all of us. If the SDK is seamlessly handling all of that operational stress out on the client side, is your backend truly locked down enough to handle the ultimate responsibility of being the secure source of truth? Definitely something to chew on as you start building. Thanks so much for joining me on today's Explainer, and happy coding.